still on the recognition and identification. We're going to talk about instrumentation just for a minute. That starts on page 49 in your manual. We won't get into a great detail on this because we feel that most maintenance people probably will not be too actively involved in it. The reason we're discussing this is just simply to introduce you to some of the instruments that are used to determine movements and locations of slides, and to make you aware of the fact that these things need to be cared for and need to be protected, and they're often very expensive instruments and very difficult to replace. Sometimes when they're torn out or through construction or maintenance activities, they simply can't be replaced and data is lost. So we'll look just briefly at some of the instruments that are involved. First of all, there's something we know as piezometers, and we've told you already that water is so important, and we often need to know where water is located in a moving mass. We need to know if it's a high water table or a low water table or whatever, and piezometers are instruments that are used to help us determine what that water pressure is and what the equivalent head is. And so we install these in a well casing, something similar to this. We drill down with a drill rig. We seal the bottom of it with some kind of a sealer or clay or something of that nature. We'll install our piezometer and backfill it with sand or something like that, and then seal the top of it, and then we'll backfill the hole. We have tubes and electrical cables, whichever the case may be. In most cases, the tubes that come out of the piezometer, and we have instrumentation that can read that water pressure. This is just a picture of some of the instrumentation that, or the control panel that reads that, gives us the location and the pressure of the water that's in the landslide. These are installed again usually in casings, or have casings that come out of the hole that help protect them. Slope inclinometers, these are very important. It's technology that's been around 20 or 25 years or something like that, but slope inclinometers have a tendency, or they're something that you install again with a drill crew, a drill rig. Install a plastic grooved casing into a drill hole and backfill it either with grout or gravel or something of that nature. We have a torpedo, what's called a torpedo. If you notice in the center of this picture, it's a silver looking thing that's inserted down into the casing that rides in the grooves with a long electrical cable that's on this reel you see in the picture here. That torpedo measures the slope of that casing. It measures how much it's moved. By the data that you get, you can tell how much it's moved, where it's moving, and the rate of movement from this instrument. So these are often used in landslide areas. Again, there's another photograph of a technician reading the inclinometer and determining what's going on at the slide site. Those are more expensive instruments. They're often at construction sites or maintenance sites. They are flagged. There will often be fence posts around them, or they'll be flagged, and special care should be taken that these aren't destroyed. We had one project recently. We lost $5,000 worth of instrumentation simply because some construction personnel were not very careful, and that's very expensive and very time-consuming to lose those. Some more simple methods, if you don't have these instruments available, and many people do not, you can simply just do ground surveys. Come out in a moving area or an area you think is unstable, establish several lines of survey lines, put in some stakes or hubs or steel pins or whatever you wish to do, and survey these into a straight line, measure levels or elevations on them, come back 6 months or however often you want to monitor it, again survey the same stakes, see how much they've moved, see how much the elevations have changed, get some idea of the extent of the moving area, or get some idea how quickly it's moving, or how what the elevation changes are. Some other simple methods that we can use for determining, again, the water table elevation. This is important. As I said a few minutes ago, we can just simply install water wells. This is plastic casing. In this photograph here, you can actually use downspout. Some people use just plain old downspout for guttering. Installed again in a drill hole, backfilled around it with soil or sand or something of this nature, and you can simply put a probe down in it. Some people actually tie a string to a rock and put that down until they hear it hit the water elevation. It's a very simple method. Don't drop rocks in it because it fills it up, but at least tie a string to a rock until you hear where the rock hits the water level, and that way you can tell the elevation of the water table. These are just very simple methods. Again, some in lieu of an expensive slope inclinometer, you can install downspout or some kind of pipe, again, in a moving mass. and ever so often come back and see if the pipe is moved by, again, putting a rock on a string or inserting something in that pipe and see how far down it goes before it's blocked or before it closes off. That'll give you an indication of where the movement is taking place as well. These are just simple methods of instrumentation. Now, another thing that we can use are just simple measurements of cracks or measurements of movements. If you've got cracks taking place in your pavement, come out on frequent intervals, measure the length of it or measure the width of it, and give you some idea if the movement's still taking place or how much it's happening. Very simple, doesn't cost much money, just a little personnel time. Of course, personnel is expensive, but just a little personnel time, and you can get some idea of what's going on at an unstable site. And one very quick thing before we... Excuse me, yes?
One of the comments that I would make in here, people to stress in this section, is that these instruments are installed to function for a long, long period of time. And just because maintenance people see them out there for years and years and years doesn't mean that they should be torn out or the protection and fencing should be torn down. Also, if they find damage to the instruments, the maintenance people will be the first ones to notice vandalism. They shouldn't just let that go unnoticed. They should report that immediately to the geotechnical people so the instrument can be reestablished and readings can continue.
Mm-hmm. Very good point, and I would like to agree again with what he has said. These are long-term instruments, and there in some cases we ourselves have had them in for 15 years. So they're very long-term instruments and need to be cared for indefinitely, as long as until maintenance people are told otherwise. In our discussion on soil and rock, there are several things that are important. We're talking about particularly soils here because landslides occur most often in soil. There are several types of basic characteristics of soils that influence the behavior of it. For those of you who are not very familiar with soil, some soils generally are coarse-grained, classified as coarse-grained or fine-grained soils, and coarse-grained soils usually consist of gravels, fine sands. Then we have the medium-sized coarse grains, which would be silt, and finally we have fine-grained soils, which are usually classified as clays. Now, usually clays are the most problem in soils and landslides, at least in the eastern portion of the country. Clays are very susceptible to water. They're very susceptible to creeping and movement. These are so fine-grained that you can't identify the soil grains by the naked eye, whereas you could in granular soils. You could see the grains, individual grains. Clays, you cannot see them, and they are very susceptible to movement. The various things affect these. Again, the grain size, the natural moisture content, as you see the slide here, affects the behavior of a landslide, how quickly it moves, if the soil is saturated, if it's very wet, if it's above what we would call the plastic limit, and I'm not going to get into that. If you're familiar with that term, the plastic limit is where the soil begins to creep under its own weight or it's highly moldable. That's the moisture content at which that occurs. If the moisture content is above that, chances are your soil is unstable and you'll have some problems. The unit weight, of course, is very important in determining the behavior of a landslide. The heavier a soil is, obviously, the more driving forces there are. That's also an important idea and important factor in the soils that you have to take into account. Now, this is I just again briefly wanted to mention those about the behavior of the soil. We're going to go right on into another section here. This is maintenance practices. This starts on page 61 of your manual. I'm going to have Tom Hopkins come back and give us the first section here talking about inventory of slope problems. But maintenance and their normal everyday practice can have a lot of influence on whether a slide is made worse or if it's stopped or if it's slowed or whatever. What they do is important. And how they handle a landslide or how they handle an unstable soil mass is so critical as to whether that thing will stabilize or move in the future. So one of the first things we want to talk about, I'm going to have Tom to mention it here, is inventorying some of these problems. Maintenance people can go a long way in helping us out in that area. So Tom, if you'll come and...
As Dave talked about earlier, we talked about distress signs and pre-slide symptoms on the highway. One of the things that highway maintenance engineers or supervisors should do is maintain a slide inventory of these problems. And also in inspection reports, there should be a written report, and these type of things should be maintained in the files. What's the purpose? Well, by looking at pre-slide symptoms, the maintenance supervisor can evaluate the condition of a highway slope. Also, any drainage structures that are located to near slopes should be noticed and notes made of. What are the benefits? Well, there's a lot of benefits that can be obtained from this. And later on this afternoon, I'm going to show you a case history in the latter session, how someone looks at a particular class of slope problems and comes up with a very good solution to it. First, first benefit the inventory can do is it helps identify potential slides. If we're particularly aware of the potential pre-slide symptoms, sometimes we can start doing things early and start planning. Another thing is it defines the scope of the slide or potential slide. Also, the inventory can help trace the progression of a slide. Some landslides occur, or the movements may occur over a period of 10, 15, 20 years. That's a long time. So by keeping track and keeping notes from year to year of what's happening at a particular section, we can start doing some pre-planning in this regard. Second, if you inventory particular sections of the highway, you can establish a priority program for allocating funds. In other words, you'll probably end up trying to treat your most serious problems first, but one thing we've noticed in highways that a landslide, or a potential landslide, I should say, it may just show some pre-slide symptoms today, but 4 or 5 years from now, it may fail. So if we're aware of looking at these symptoms and know and classify different sections of highway, especially the distress sections, then we can start seeing how we should allocate our funds for repairs. Other benefits, well, as I've just talked about, we get historical data. This is really, really important for the geotechnical engineer. If you have to call in a geotechnical consultant or consult with the state's geotechnical staff, having this historical data is a real important thing, because he doesn't have to do a lot of the footwork. A lot of times he's a very busy person, and he'll have to go out and get that data. But if you've got it in the file, you can hand him a folder if it's a large slide that we're dealing with, and he can review it quickly. Another thing is that it opens up communications, and I think this is very, very important between the maintenance supervisors, maintenance personnel, and geotechnical staff. Also, one of the big comments that Dave and I encountered when we were putting together this course, we don't have enough money to repair landslides. Well, with an inventory system and by classifying your problem and having the data, it's a lot easier to go into some administrator and convince him that you need future funds if you've got your homework done. So this is a way of doing homework. And finally, the most important thing, it gives you a course of action. It organizes you in the sense that you can decide, what am I going to do, which slides am I going to treat first, and so on. One thing that we would recommend from this course is that maybe periodically maintenance people and geotechnical engineers, like on a state level, get together, have a joint review of some of the data. This would help a lot in establishing priorities for maintenance. One place we could start, perhaps, is to start reviewing maintenance records, maintenance cost. Every locality should establish some type of inventory and also take a look at what problems are occurring. For example, we might start by looking where there's numerous overlays. This is an indication that maybe there's certain distressed sections occurring, that possibly landslide problems are developing. By looking at these places, for example, if we've patched the place for 2 or 3 times, we've probably got a slide problem developing, most likely, because that embankment settled several inches. So look at numerous overlays in this joint review. Pavement cracks, as Dave talked about earlier. This is an indication that maybe some real serious problems are going to develop. Make notes in the inventory where those cracks are occurring. Previous slide repairs. Just because you go out and repair a landslide, don't assume that it's going to stay there. Failures occur after you repair them. So don't make the assumption that because maybe you let something out to a contractor, that he's an expert in landslides, he repaired it, I have no more problems there. Always go back in the inventory system and review that slide. Keep a track, because like I say, sometimes landslides take 10 or 15 years to move. Should be a periodic inspection. We would look at those first three things first. Maybe the joint review would look at fill and cut slopes. In setting up the inventory system, we probably would want to set some criteria there: critical steepness of the slope and height. What we would recommend, any embankment over 50 feet in height, and we're talking about from measuring the height from the toe of the field up to the top of the slope as the distance we're talking about here. Anything over 50 feet and anything less than 2 horizontal to 1 vertical slope probably should be included in the record, because large fields settle a lot, but oftentimes this is where we have some of our major problems. And this could be a 2-lane county road that has a slope that goes could be 50 feet in height. And another thing that should be included in the inventory system is all drainage features, as Dave talked about earlier. And of course, all known slides and slip outs and rock falls should be included. And you should have in your record, or have a mechanism where you can have a schedule for updates on those. Now, in your manual, Appendix A is pre-slide symptoms and so forth. This part of the manual can be pulled out by the maintenance personnel and carried in the truck. It gives you some information on things to look for and so on. Of course, after you do the inventory, you should classify the landslide. Very serious, medium, or minor, whether on the condition of the slope. A very serious problem, of course, would be one where the pavement or the embankment is dropped 6 inches, and it's a very hazard to the traffic. Obviously, a case like this needs a lot of attention, and you're going to have to do something fast. A serious problem may be one that you've patched 4 or 5 times. It needs some type of investigation conducted, and possibly, or probably, most likely, you're going to have to repair the embankment slope. Medium, well, you need to keep a close check on the embankment. Maybe you passed it once. Maybe there's a slight crack or a little bit of movement on the guardrail. So it should be included in your inventory system. One that you keep your eye on. Minor, well, that'd just be maybe a patch in the surface or something, maybe one patch in 2. But you would have to come up with your own sort of system, but this is one suggested way of looking at or classifying the condition of a slope. Things that you could include on the slide inventory inspection report, or just things, these are listed in your manual. Location data, make a note of where it is. It's so many miles from some known feature, or a milepost number, or something of that type. Type of slide. Now, I'd like to mention one thing, that in your appendix we've included a sample slide inventory inspection report. This is just a sample. You may have to massage this to fit your own particular local conditions. But the type of slides we talked about earlier in one of the earlier session are in that inventory, and so you could simply circle if you can guess, or if you study this enough, you could probably get familiar with the typical slides and be able to mark it. Other contributing factors, other things that you may note, as shown here, whether it's a bulge at the toe or a scarp, cattails growing, as Dave mentioned earlier, at the toe there. It's good to make a sketch of the site and measure these things, put them on a sketch and indicate there, because later on when we talk about subsurface waters and how to treat that, cattails and signs of springs, that gives you an indication where you might start trying to make a repair and something to do, or try to lower the groundwater table in the slide. Other things is if it's above the roadway, you need to make an indication in the form. And as we mentioned earlier, the type of slide above the road, whether it's a mud flow or so on. Other inspection data, which is listed in your manual. Rate of movement, Dave talked about simple things we could do. Measuring cracks and periodically measuring the width of the crack gives you an indication how fast the thing's moving. What effect it might, if the thing fell, what effect would it have on the roadway? Would it endanger the public in some form or whatever? Whether there's utilities located close to the site, such as telephone poles. These are kinds of data that should go on the form. Whether adjacent properties would be involved. In other words, is there a $10 million building sitting at the top of the slope? These are the kinds of things you should indicate. And any other type of maintenance activity. And like I say, you should make additional notes and sketches. A good thing to do is take photographs. You may want to try to get cross-sections of the highway embankment. You may not include all of this data in there, but at least include some of it. It's preferable, of course, to include all the data. And estimate repair cost. Well, we're going to give, after a while, a later session, give you a real quick way, just giving a quick estimate of what it would cost if this main embankment fell, what it would cost to repair it. And then you should do a follow-up report. A simple things, do a profile or take a cross-section. This is a simple way of estimating how deep the failure is. The details of this technique is explained in your manual. There's useful items for inspection that when you make an inspection, things you should take along. Of course, you should take a notepad. This sounds a little bit crazy, but you'll be surprised how often I go out sometimes and forget to take the things I need. A notepad to take notes and make sketches. You need a camera. This is one of the most important items you can take on an inspection, and I'd like to really emphasize this. And also, when you take shots, mount slides. You can either do slides or photographs. Slides are convenient, and one good thing about taking land slides, if you have this joint review and you have slides, but when you get together, you can talk with the geotechnical staff and the maintenance supervisor and maintenance engineers can get together. Well, they can flip through and show slides of the problem, so that the both groups can get a feeling for the magnitude of the problem. Take some well-placed photographs. For example, this is a system that's used in Kentucky by the geotechnical branch of the Kentucky Department of Highways. They came up with a scheme of using a number. They painted large numbers. So they show they take a good shot of the pavement. You can notice there's dips in the guardrail there. Well, that's significant. That's showing something there. Take a shot of the slope. You may have to walk several feet, hundreds of feet back to get a wide-angle shot like that, but it's good to get a good shot there. You see the man in the photograph there, he's standing on the top of a scarp there. There's a slight break in the ground there. That's highly significant, and this photograph shows that fairly well. Drainage structures. Here again, he's at the same location. The slide is numbered. Another shot of the drainage there. It's difficult to see in that shot, but if you look in the lower part of the inlet there, there's mud there. That's very significant. That means maybe the pipe's broken. possibly, and mud is oozing from inside the embankment down through the joint into the pipe. A cloth tape. That is one of the most important things to take, because when you're looking at a distress section where there's slight movement, a little failure's occurred, you want to measure the width of it. Another useful item is a hand level. You may want to take a quick cross-section, and this is something that maintenance could learn to do. Take a real quick cross-section, because taking that cross-section, you can possibly pick up the bulge where a bulge may be occurring in the toe of the embankment. And of course the compass gives you the direction which you can note the north arrow on the slide. One suggestion, and I don't think maintenance would be involved in this, but it's something that maintenance and other people should think about, is setting up a system which you could take the sample form in the manual, computerize the data. So it'd be very simple. You can make a formatted form for maintenance to carry out. They could fill it in and then type it in, and then you could easily update these slides. Like I say, that's not a real concern maybe perhaps to the maintenance supervisor. He's got other problems on his hand, but it's something that other people in the state should be aware of. And finally, we need to have in this type of system some type of central control or central review authority. There needs to be a mechanism set up where people can get together periodically and review all these maintenance problems. Okay, I'm going to turn the program at this point back over to Dave Allen. Oh.
We're still under maintenance practices. We're going to begin on page 70 in your manual under slope maintenance. Now, what we're about to discuss are some suggestions that we would have for maintenance people. These are just, we'll show some examples from the slides and sketches here of some of the situations that we've found or we have collected here, and some suggestions for maintenance people to do in situations like these. First of all, we're going to talk about maintenance of the slopes themselves. For instance, if you've got an erosion problem, how are we going to do this? What do we need to look at when we are going through on our maintenance activities? We have an erosion problem. What are some of the things we need to maintain or take care of? For instance, this is an example here in this slide of an interception ditch. This is at the top of a slope. One thing that most people, I believe, are not fully aware of is how delicate or how fragile really a soil slope is. And interception ditches, for instance, are used to stop erosion, to keep the water from going over the slope or running down over the slope. And these things, when maintenance people go out and look at these things, need to be aware of the fact that, hey, let's look at this. Is there a crack in this? If it's just a small crack, maybe we can stop it, keep water from going down in it and eroding out underneath of it. Let's look at that a little more closely. This is one thing they need to examine. Look, for instance, at this one. This is a maintenance problem. The only thing that probably can be done with this particular paved trench now is to remove it. And either, if you don't want to repave it, which would be a major job, at least put large stone back in the ditch. This probably is this will get worse. There's no doubt about it. This will get worse. Maintenance need to come in and just simply try to stop it, try to slow it down by putting large stone in it, either removing the trench or the ditch completely and replacing it with stone, or else probably let a contract and have it replaced. These ditches are so important. Any amount of water that gets under a paved ditch is going to begin to create a problem. And the first crack that gets in a paved ditch, that water's going to find its way into it and down under that ditch. Here's just another picture of one that needs to be worked on. Again, the only thing you can do with this without too much expensive repair is simply replace it and just put large stone in it. And here's one that's totally eroded away. Notice the pond of water standing here. There are two ditches that came into this point here, and the situation is critical here. It needs to be come in and drained, and about the only thing that could be done here in this situation, again, is either to repair the ditch to its original shape by paving a new one, or else come in and remove the water and just simply fill it with large stone. Here's a situation that the whole first section of a pipe has been eroded out. The pipe is, notice the tree growing up next to it there, and the pipe is simply, the first section is about to lose it, possibly even the head wall. The thing to do there is, of course, to come in, again, I would suggest granular material here, come in and backfill around this and smooth the slope out, either with a little bit of soil on top of the granular material and reseed it, or else something of that nature. But this needs to be corrected immediately, else the situation will get worse, the slope will get unstable, you'll lose more of your pipe, and you'll have a major repair problem there. I showed this slide a while ago, but just to re-emphasize, this needs to be refilled, again, probably with granular material, possibly an asphalt coat on top of it as it originally was, and more importantly, some sort of drainage needs to be provided there. And I'll talk a little bit more about bridge-in drainage in a few minutes, but some kind of drainage to prevent that erosion from occurring again needs to be provided. A pipe, a paved flume, or something of that nature to carry the water from the end of the bridge. Here's a situation where the toe of a slope was eroded out by the forces of the river. This was on the outside of a curve of a river. Where the big truck is there, you'll see that there was a large, or there was, before the maintenance got a hold of it, there was a large hole there where the current, an eddy current, had eaten out the toe of the embankment. This embankment was moving. Matter of fact, it was a critical situation, and one of the problems was the fact that erosion had removed the toe support, and as I said a while ago, you remove the toe support, you remove or you increase the likelihood of a landslide occurring, so they came in and filled this with large granular material that would not be susceptible to erosion by the stream current. Here's sheet erosion, what I call sheet erosion. This is along the edge of a pavement where simply the water that comes off of the pavement washes over the shoulder. The shoulder has been partially stabilized in the past, but the stabilization has still continued to allow the soil underneath to erode, and we get a situation like this. Now this water is going to continue to erode the embankment further on down, either saturate the embankment or cause further deeper gullies on the slope and possibly destabilize the slope. This again, these gullies need to be filled in and some sort of stabilization put on that shoulder. And again, an asphalt overlay or an asphalt chip seal or something of that nature to hold the soil in place. Here's a shoulder here that had been subjected to sheet erosion, and they've simply come in and put some thin concrete, some grout, and spread it over the slope to prevent any further erosion at this point. Now here's the situation. If you notice across the center of the picture, the guardrail on the lower roadway here, there is a small berm there, an asphalt berm. These are very, very important to repair. These berms keep the water that's coming off of your pavement from flowing down over the slope, and particularly in a curved section or a super elevated section where you're getting the water from the entire paved surface. Oftentimes if you let the water run over that slope, you get the situation that I showed just a second ago, that erosion. These asphalt or concrete berms, not berms, but curbs here, keep the water from going down over the slope and preventing that erosion that you see. This way you can channel the water to one location and run it down a paved flume or a paved ditch to the toe of the slope. Here's in an urban area. Notice this curb drain here is not doing much good. It may be catching some of the water in real heavy flow, but if you'll notice that the slab, the concrete slab, has settled relative to the curb, most of the water is going down around that curb and down underneath of it, and you can see that the pavement there is not in real good shape, probably because of the water that's going underneath. What needs to be done there is this crack needs to be repaved. An asphalt overlay probably would be the cheapest thing to do there, and bring that up to at least the grade of the gutter and seal that area. So just a little sketch here to show us the interception ditches are important. Repair the curbs or the that I showed you there in the city or out the curb to keep the water from going over the slope. Any area that maintenance gets out in and tries to repair or makes repairs on, if they have to disturb the slope and leave just bare soil there that needs to be reseeded and repaired. These are things, just simple things that maintenance can do to help in the stabilization of slopes. Here's we will talk just a minute about vegetation and how it can help us out. Here's a slope here that is not properly seeded. Notice the erosion that's already started to take place. This is a fairly new slope, but erosion has already started to take place. There are two diagonal lines going across the picture there down across that slope. Notice there are gullies that are forming. And notice where those gullies come down on the steeper portion of the cut. They've already started a fairly steep erosion problem there. Now, what's going to happen is those gullies are going to get deeper, and there are going to be some small slides and slumps that occur across that slope. So maintenance, as they find this, need to come back. If the thing was not seeded properly in the beginning, then it needs to be reseeded and hopefully to stop the erosion. Here's another problem with erosion and improper seeding. This slope here was not properly seeded. Not only do we see small gullies that are starting on that slope, notice what's happening there at the mouth or the inlet of that culvert. It's beginning to fill up and silt up, and before too long we'll have a blocked culvert and more water standing at the toe, and the situation just simply gets worse. So again, maintenance should come back, make sure that's reseeded, and come back and clean that culvert out and try to stop the erosion at that point. Here's just an example. Everyone's seen this, but this is a type of netting and straw and seeding that helps to hold slopes. Here's another slope that has been just recently repaired. Notice it's covered with straw and a stabilizer, in this case a net, that helps to hold the soil and the seed in place until some form of sod gets started. So anytime maintenance does any kind of work like this, it would disturb the soil and leave bare soil out, and they should come back and reseed it very carefully. Here's another interesting thing. Now, we've talked about cattails earlier this morning being an indication of where water is. You can use sometimes plants to, this is one that's probably not thought of very often, but maintenance can use plants sometimes to help a landslide situation. These water-loving plants, cattails and willow trees and other things that like water, if you've got a small area that is soft or muddy, but the area maybe is not moving yet, you can stabilize that area or help to stabilize that area by planting some of these shrubs or some of these bushes and weeds, and help to absorb some of the excess water that's coming out of sight. Some people have used this, and it works mostly in small areas where you have just small muddy areas. Here's a ditch here that obviously we've shown several of these pictures already this morning, but notice as you go around the curve to the right there is a blockage of vegetation. That's too much vegetation in the ditch. The vegetation has blocked the ditch. We know that it is important to have vegetation to avoid erosion if you don't have a paved ditch, but this is too much. And maintenance could alleviate this ponding water here by coming in and cutting some of that vegetation out, letting the water go on down grade around the curve. Here's one, I showed this as an example of just exactly what good vegetation is. There's a small culvert there, if you can see it up to the top right of the picture. Notice in the bottom of the flow line here, you can see some water flowing there. There's good grass cover there. It's not impeding the water in any sense of the word. It's letting the water flow on through, but there's no erosion. If you can see the water there, it's clear. There's no mud in it. There's no erosion taking place, and just a perfect amount of vegetation in that ditch. The flow line of that ditch, that's in a low flow area, but if you notice it's considerably wider. It covers most of the picture there, but in high flow areas there's still plenty of good vegetation along that flow line to keep erosion from occurring. This is an example of what really a grass ditch should look like. Here's really a serious problem in some areas of the country. We have very unstable slopes in many parts of the nation, in particularly high water areas or high rainfall areas, but it's letting the maintenance people, whether they're contract maintenance or whether they're state forces, it's letting them get on those saturated slopes or wet slopes while they're still very, very soft. This tractor here is pulling the mower across it, but notice what the tractor can do in this sketch. He can cause tire tracks, he can cause tire prints, the mower can cause rutting in the side of the embankment. Look at this one. It's totally crisscrossed with mower tracks and tractor tracks. Water stands in these ruts, by the way, continuing to soften, particularly the top few inches of that slope, the top embankment, and can cause shallow slumps, if nothing else, in that slope. Cause the soil and the sod, I should say, to break and let water down into that embankment. There's another example of a slope that is, notice in one place here to the right center of your picture, there's the water actually standing in one of those ruts. And so it's a very, very serious problem in some areas of the country. So maintenance people should stay off of these slopes while it's wet, if possible, and to prevent this sort of thing taking place. Here's another very poor example. As a matter of fact, this is the beginning of a landslide. I suspect that that was caused in part, or if not completely, by the fact that those mowing tracks were on that very fragile slope, and you see an escarpment starting there and a small bulge at the bottom, probably from mowing practices. Now, rock falls, which we've talked about several times this morning, let's see what maintenance can do with them. Oftentimes, these things are very difficult to repair. Rock falls are something that oftentimes, large rock falls are beyond the scope of maintenance. But if it's a continuing problem of debris falling on a roadway, if it's a continuing problem at one location, maintenance can do some things about it. For instance, this slide shows a large crack in a large cut here. This goes back to the inventory that we talked about a few minutes ago. Maintenance people should be aware of these types of locations and kind of note these things, that there's a possibility, a very real possibility, that that large crack is going to cause some large boulders to fall off in the future. Maybe another winter or another season, and they may have a serious problem here. Probably at the moment, unless doing anything about that may be beyond the scope of most maintenance forces, small maintenance forces, but at least they need to be aware of it. And here's a crack in a wall. That's going to, one of these days, before too many seasons, that's going to be a failure. As a matter of fact, this one did fail. Unfortunately, that slide doesn't show, but it did fail. There are some things that can happen here that we can do, maintenance can do, not so much from, at least in the beginning, from stabilizing the slopes, but from protection more than anything. Notice in this slide here, the wall is screened. It has a screen on it to prevent debris from falling down on the roadway. Also, there is a zone there to tow that slope, that the debris, if there's any, falls out from under that screen. There's an area there with some width there to let the debris fall in. Also, there is a small berm there, a rock berm, wire-filled baskets there that help to prevent the debris from bouncing up onto the roadway. These are important. These are things that maintenance can do. Rockfall area here, a barrier which can be used. There are different types of barriers. Tom will talk about them some more in detail later this afternoon, but here's just an example of a fence that's been constructed to keep the debris off from the slope from falling out onto the roadway. And the other thing that I want to emphasize in this part for maintenance, and this is the most critical part for them, is just simply to keep fallen debris cleaned up. Keep it out of the ditches and to prevent water from ponding. And if there is a slope that continues to present problems, once in a while coming out and scaling these slopes, that is, by that I mean cleaning off the loose rock and the debris that's about to fall. We see in this frame here our maintenance crew out scaling a badly weathered slope. And this needs to be done as frequently as the crew foreman thinks is important or is necessary. So that's mainly what maintenance can do in rockfall areas. But if you're cleaning a slope or you're scaling a slope, one thing, there's a right way and a wrong way of doing it. And particularly as you see in this slide here, with the equipment that the maintenance crew has, they should not come in and undercut those harder overlayers as they clean those ditches out. As you see there at the lower left-hand part of the picture where it says incorrect, don't cut underneath that layer, but pretty much as it says there where it says correct, bring that slope down in a smooth grade, leaving as much support as possible for that hard overlayer of rock there. Here's an example of a situation. This slope has been cleaned in the not too distant past. Notice it has been done pretty well. There's some overhanging material there that may have weathered a little bit since the cleaning was done, but the point I want to illustrate there is that poor material underneath, probably a shale, has been brought down pretty much at a straight angle and is pretty well been scaled. Irrigation is something that takes place in the western portion of the country, not so much in the east. If there is irrigation that takes place, there are a couple of facts, just very quick facts that need to be remembered. Do not overwater. Even though it's important to keep vegetation growing, do not overwater the vegetation and cause the slope to become totally saturated. Or if you've got a irrigation system, check the system out frequently for leaks. or else you'll be saturating the embankment in one location and cause an unstable situation there. Let's look at, for a moment, at maintenance of small slides. I think, though, before we get into that, we'll just simply stop here our tape, and we'll start a major topic here in just a minute. Take another break. Now we're under a section on small slide maintenance. Now many of the slides that we've shown in this workshop have been fairly sizable slides. The reason that we've done that is many people don't take pictures of small slides. They're not dramatic, so they're hard to find. But the principles that govern in a small slide or a large slide are the same. So the principles that we're illustrating, regardless of whether it's a small or large, will still apply to what we're doing here. On small slide maintenance, if you have a small slide that does occur on some of your slopes that's not major yet or something that maintenance people can handle, there are some do's and don'ts that we need to remember as we go through and deal with these things. And some of these are, one of the most important is obviously to direct water away from the slide. Again, we're coming back to this whole thing of water. We've got to hit it again. Keep water away from the slide. This little sketch we've shown here, if you've got a paved ditch that the slide has flowed over and partially blocked, if you can clean that ditch or move the ditch some way, Tom mentioned that earlier this morning, and keep the water from running into the toe of that slide and continuing to saturate it, you are helping your situation out a whole lot by keeping that toe as dry as possible. There's just another sketch illustrating the same thing. If you've got a pipe, or if you've got a ditch at the top of a roadway that's putting water down into an unstable area, that needs to be moved some way. Either run the water on, or else change the direction of the flow, add a new ditch or a new pipe, and change the direction some way to avoid that little small unstable area. Here's a bad situation here. Notice this landslide. There's a real good clue as to what happened to that particular site. There's about a 4-inch PVC pipe that's run right out into the middle of it. So there's a good reason there, or good thought there, that possibly that slide was caused by that pipe. That should never have been permitted, by the way. That was a private pipe that came out onto the highways right away. So that is obviously something that maintenance can take care of and remove. If you've got any cracks, tension cracks from a slide or an unstable area, these things ought to be sealed. It is amazing, and Tom will probably mention this later this afternoon, but it is amazing how much pressure or force just a little bit of water in a tension crack can put on that slide. It is a tremendous amount of pressure. Not only does it put pressure on the slide, but it also helps to saturate that failure plane as it seeps down into it. So if there are cracks that have occurred, by all means, it's very important for maintenance people as much as possible to keep those things sealed and filled up. If you've got a small area, we've talked to some maintenance people around the country, maintenance supervisors, and we have asked them what is one of the first things you do if you've got a small slide, and they almost entirely, the first thing they'll say is, if I've got material available, I'll try to flatten the slope. There's nothing wrong with that if you don't interrupt the drainage from that slope, or if you don't, if you've got the right-of-way and the area to do it, then try to waste the material at the toe of the slope. That's not, we want to emphasize that it should not be at the top of it, but at the toe of the slope. That's where the support is needed, and it's important to remember that. So that's not a bad idea. Matter of fact, it's probably cheap in many cases if it's a small area and you've got a small crew to just simply waste stuff at the toe of the slope. And again, I emphasize at the toe. Now, another thing you can do in a small, very small slide, maintenance people can do, as you see here in the sketch, is simply just remove the bad material. If it's not a deep failure, if it's not down several tens of feet deep, if it's just mostly a slough on the slope, you can remove it. Oftentimes, just simply a few inches or a few feet below the extent of the sod. remove that and replace it. Here's an example of where that's been done. They haven't completed repair of this, but notice half of it at least has been repaired. They've simply removed that and have taken the bad material and filled it with some large granular material. That's a very cheap solution, very easy to do in small, shallow slides as shown here. Some other things that you should not do, and I've mentioned them already, but don't excavate the toe of the slope. Don't remove any kind of lateral support. And obviously don't pond water around the slide anywhere or unstable area if you've got one. And don't load the top of the fill. And I've got that in capital letters. Don't load the top of the fill. It's called side casting, I think, in that little yellow handout. Don't do that. That's the worst thing you can do. Putting material at the top of the slope here only adds to the driving forces that Tom discussed earlier in the course. Only adds to it and makes the situation worse. Obviously, it's a good place to dump waste material if you're cleaning ditches or so forth, but you're just creating another problem somewhere else. The little dashed line there in that sketch indicates the possibility of a failure plane developing there. Here's an example of some side casting that's done. As a matter of fact, this is even worse. It's right inside the guardrail. They haven't even bothered to remove it outside the guardrail. I'm not going to show you any further where that one was. Here's another bad example of what not to do. I've seen in many places around the country where people have tried to repair landslides by just simply dumping it over the top. Just putting, if you've got a slough that starts, they'll come in with granular material. They've tried that with granular material. I think there's also a dump there, looks like, but of trash and everything else. But they've tried to repair that. You notice the edge of the pavement over here to the left, and they've simply dumped in granular material. Well, that's not helping them very much by putting it there at the top of the slope. Here's another example of some things that should not be done. We recognize, or well, maybe I should back that up just a minute, that's not helping you in any way when you try to repair a slide by continuing to pave it. Again, we recognize that maintenance must keep the roadway open by patching it, and that is a concern to keep the roadway open. But when we do this, we of course are adding more and more weight to the driving side of the landslide and creating more problems, and eventually something will have to be done more permanently. There's another example of the same kind of a situation where many feet have been added. I've heard examples of stories of much as 26 feet of asphalt in some cases have been added over the years to a landslide to the top of it, where maintenance has come in and had to continually keep the road open and put more asphalt in. So that can really add up to a weight. There's another smaller example of the same type of situation.
Question.
Yes.
When you're flattening a slope, even a small one, are you recommending that they strip the existing topsoil and vegetation and key the slope?
Most of the cases that probably would be best to do. I would agree that it would be best to do, but a lot of times it's not done. And if the material is added to the toe of it, and it is a small slide, I don't think that it would be too harmful if you just simply put it at the toe and dumped it there. Is there anybody else want to comment on that? You agree or disagree with that?
Well,
Yes,
one other point, David, that I just thought is that you talk about side casting, and we've emphasized that, and I think if nothing else comes out of the course and you recognize the side casting as a bad thing, that's great. But one thing I was thinking in the areas where you do have problems with your embankments and also your cuts, you clean out the ditches, you can cure two problems. So you go out and you clean out the ditches, and that material, instead of casting on the side, you take it down to the bottom and put the berms like you're talking about. So it's really economical to cure two problems.
Sure. Richard, did that pretty well answer
Yeah, I
your
was
question?
wondering what you were recommending.
Yeah.
Question.
All right. Let's go to drainage and maintaining drainage then. In developing this course, we had some discussion as to the proper location for these, and we kind of came to the conclusion, and you may have been able to organize it a little bit differently, but we came to the conclusion that probably the best place to put surface drainage would be under maintenance practices, because we feel that most of the time maintenance is more concerned with surface drainage than they possibly would be with under our subsurface drainage. So we will discuss mostly here surface drainage and just briefly touch on subsurface drainage, but later in the afternoon Tom will discuss subsurface drainage in more detail. Surface drainage is located in page 88, or actually page 79, excuse me, in your manual. Now, surface water is obviously very important in where it goes and what we do with it. Again, I told you earlier about blocking of culverts. Culverts blocked that do not let water flow properly and back up near the toe of embankments are problems. Here's an example here of a culvert that needs to be cleaned out. This is debris in front of a very large culvert. The driftwood and so forth needs to be cleaned away, but when you do that, do better than this crew did. Notice where they put the debris. They put it right back on the bank where high water will wash it right back where it was. So when you clean out a culvert and clean the debris away, make sure that you carry it away and keep it out of the pattern of flow and clean it completely out. Here's an example of, there's a head wall in that picture. It's a dark picture in the shadow, but there you can see a head wall there. Somewhere under that debris there probably is a culvert. And that, of course, needs to very simply be cleaned out, cleaned away. Ponding water in a ditch, again, we've been talked about that numerous times, but any debris, whether it's vegetation, whether it's rock, whether it's soil, or whatever it might be, the first thing is to get it out, get it away, and move it away from the flow pattern of the water so that it doesn't wash back down into the channel. Here's some, in an urban area, here's some debris, just trash and grass, vegetation. Vegetation, mown vegetation is a very big contributor to debris in ditches, particularly paved ditches. Here's another urban shot of just junk from a shopping center that's flowed down into, at the toe of a slope or in a paved channel, and it won't be long before that culvert is completely blocked and saturating the toe of the slope. Underneath, you can see there at the right lower portion of the picture, there's a paved ditch there. And at the end of that paved ditch somewhere, there's a drain. As you can see, the washing and the debris and the trash has totally blocked that, and I'm surprised that paved channel is flowing as well as it is. Apparently it is still working some. But of course, that needs to be cleaned out and maintained quite frequently, all of the trash removed. Here's one that maintenance must keep on top of all of the time. Again, just trash in the ditch, in the flow line, backing up water. If that doesn't saturate your embankment, it at least probably is saturating a portion of your subgrade, which is not a part of this course, but it is a problem. Pipes in unstable areas or is something that needs to be have special attention paid to it. Any pipe that has a joint that's separated, it's going to permit water again. Like a paved ditch, it's going to permit water to flow underneath that. It's going to do one of two things. It's going to erode out around the pipe, and if it's toward the end of the culvert, you're going to lose that section possibly, or else it's simply going to saturate the foundation or saturate the embankment, and again, provide a source of moisture and for the soil to weaken and cause possibly a landslide. Here's a perfect example of a separated pipe joint. Notice the roots that are growing down in it. If there's a lot of water that's in that embankment, it can easily erode some of the soil around that pipe down into the pipe. And Tom showed you a quick example of that a while ago on another slide. And that should always be taken care of. Those joints should be sealed, and there are different ways to seal those depending on how far apart they're separated. You can come in with grout, or you can come in with bituminous material. You can do other things to seal those joints, but they should definitely be sealed at all costs. A pipe in an unstable area, a rigid pipe, particularly in an unstable area, is a source of problems that maintenance should be aware of. If there is movement, that rigid pipe cannot take movement very well without separating at the joints. And when you get a joint separated, again, you've got water saturating your fill or your foundation or whatever. Notice this situation here. The pipe in the distance there, the section in the distance has settled relative to the pipe in the foreground, the immediate foreground. You've got soil, you've got grass, roots, and everything coming into your culvert. Probably the water that's flowing through this is flowing out into the embankment or into the foundation, giving you some problems in soft areas. Here's one that maintenance should be aware of. Don't ever try to put in two different size pipes. That's what's happened here. You notice the pipe section in the foreground is much larger than the one in the next section on down. Not only do we have water, we've got roots and grass and everything else coming into this. This is a perfect source for water, not water, but soil to erode. around that smaller pipe and come into your larger section here. So maintenance, when they try to repair pipe, of course, that's a very simple rule, but always at least use the proper size pipe when you're trying to repair it. Inlets and outlets ought to be protected very carefully, and this is a very simple, again, rule. Everybody knows that, but we don't always pay attention to it. Where water flows out of a culvert or water flows into a culvert, there need to be head walls around them, by all means. If there's a head wall problem, if one is deteriorated, it ought to be replaced. This is a pipe here that fills the screen mostly, but you can see that it has no head wall. There's erosion that's occurring around that pipe. There definitely should be a head wall and probably a paved flume or a gravel or large stone trench that takes the water away from the outlet here. Here's a small one. Now that looks like a small problem actually to maintenance. You could say, well, that's not going to cause too much trouble, but notice that a very small pipe, how large is the area that's eroded around it. There's no head wall there, no protection or no gravel at all. That ought to be taken care of, probably with gravel or with a little bit of concrete to keep that eroded area from working its way up the slope or up the side of the slope. A short pipe that empties on the slope, this is some that I've seen in many cases, a pipe that just simply comes out. In this case, this slide here shows underneath the pavement, but I've seen many drainage structures where the pipe simply comes out on the side of the embankment, dumping water out onto the slope, saturating or eroding the slope. That's another thing that maintenance should be aware of. If we install a pipe, if we repair a pipe, why not increase the length of that pipe until it runs away from the slope completely and on out beyond the toe? And when you're cleaning ditches, over-excavation of the ditch, and I mentioned this briefly in talking about scaling rock slopes, but the same thing holds true for soil ditches. If we're excavating a ditch, let's not over-excavate it and undercut, again, the support of the cut slope. You notice here where I've got sketched here, ponded water in the ditch, where it's been over-excavated. It can soften the slope if it's has been undercut any, or else if the water ponds in the ditch, it can saturate the embankment, causing a slide in more than one area, at the toe of the cut slope or at the toe of the fill slope either. Here's an example of somebody that's cutting out a ditch. Notice I wanted to point out something in this photograph here. They're doing a pretty good job, actually. They're cutting a rather smooth-sided ditch. Notice that off to the right of the slide, the photograph there, the side of the bank that they're cutting there is very smooth. It's not undercut. They're really doing a pretty good job. Maybe the safety people wouldn't appreciate that ditch being so close to the shoulder, but nonetheless, the shape of the ditch and everything that they're doing here appears to be pretty good. Other things in drainage that we don't think about often that we can use to, maintenance can use very cheaply. If we've got ditches that are eroding, or ditches that we have continuous problems with, things such as ditch checks can be used. In this case, it's just simply a small gravel berm or a small gravel dam is being used to slow the velocity of the water down. These can be used very, very cheaply in ditches and kind of create small pools where the velocity of the water is slower. One thing in ditches, and it's very important for maintenance people to realize, when they're cleaning ditches or when they're working with ditches, do not change, if possible, do not change the shape of the ditch. Anytime there's a change in the shape of the ditch, you change the velocity of the water. And whenever you change the velocity of the water, you're either going to get siltation or you're going to get erosion, depending on how the shape change is. So as much as possible, maintenance people should keep the ditch shape uniform throughout the entire length of the ditch to avoid any kind of change in water velocity. Here's another example of a ditch check to reduce the flow or the velocity of the water. This is an asphalt one. They've just created small steps in that ditch and are doing a very effective job. Here's one that's rather interesting. It's from the slide. It's difficult to see the shape, but there are small asphalt dams in that ditch there. That's a paved ditch, and there are small asphalt dams there that are creating little pools of water that slow the velocity of the water. I think that's a very, very clever and very cheap idea that maintenance can use. Here's something very simple. It's just simply a silt check or a silt fence, if you want to call it that. Now, I suspect that's not a very permanent solution, and those silt fences wouldn't remain there very long. But if you're in an emergency situation and you're trying to slow the water and slow erosion, a silt fence would be a solution that would be temporary. It could be used. Again, subsurface drainage, we won't talk much about this morning. We'll just move on to that very quickly. Subsurface drainage is something that used to carry the water out of a landslide if it's in a slide area, or if you've got pipes that you're trying to drain a certain area and you've got perforated pipe in it. It's always good to bury that pipe in a trench, backfill it with gravel or geotextiles that can be used to keep silt and mud from filling up your gravel ditch. These are things that can be used always. Here's just an example of how these are put in. Everybody's seen these type drains put in. Very simple to install, something maintenance could do in a slide area if they're trying to drain that or even collect surface water into a drain like that. Very simple to install. Any kind of drainage structure you've got ought to be repaired and checked. If there are siphons, if there are manholes, if there are large pipes, or whatever you've got on your drainage system, these ought to be inspected frequently. Again, this is I just threw this slide in to show you a rather complicated structure to prevent high velocity water from eroding out a particular trench or ditch. But these things ought to be checked. They ought to be kept clean, and ought to be aware of the fact that these things do need maintenance. We just simply can't forget about them. Another thing here for maintenance, oftentimes they are required to come in and maybe repair a pavement or repair a small section or patch something, and in so doing they have to regrade the slope. When you do that, maintenance people should be aware of the fact that most pavements need some way of daylighting the water that gets into them. When I say daylighting, I mean to let the water get out the side of it in some fashion. If edge drains aren't used, and they're being used often on many high-type highways now, but if edge drains aren't being used on small county roads, and most of them don't have them, then when you regrade the slopes, provide a means of escape for the water out of the pavement. The pavement's probably going to get water in it through cracks, through fissures, through joints, if it's an old concrete pavement. And when we regrade the slope, if you notice over to the right and over to the left of that pavement, that the soil there probably is pretty impermeable, and it's going to probably pond water. And either that water is going to saturate the slope at that point, maybe create a small slide, or else, if nothing else, it's going to keep these subgrades saturated. So running the gravel or a permeable gravel out to the edge of the slope probably is the best solution. Don't build, as it's called in this slide, a bathtub situation, where the impermeable soil at the edge of the pavement keeps that water from draining away very quickly. Here's just an example of a bathtub situation. Notice the water that's coming out of that median. It has no place to go, so it simply comes out onto the pavement there, as you can see just to the right of the center of the picture, coming out on the pavement, probably running through the cracks in that pavement and down into the subgrade. Maintenance around structures, and specifically I'm talking about bridges at this point, for they're most of the time our most important structures that we have. Maintenance around them and how surface water runs is very important. Always, and I've showed the slide twice so far this morning, always provide drainage at the bridge end. Some way for that water that's coming down the pavement to get off of that bridge and away from the bridge and away from the slope. That's very critically important. This is a sketch that shows a flume. Some states and some agencies or some counties use drop inlets and carry the pipe or the water away in a pipe, and that's well and good also. But some means or some method needs to be used to carry the water away from the end of that bridge. It comes down the pavement. Notice I'm going to show you a few slides here to show you the problem that we are having, that maintenance is having, trying to keep the water from eroding our slopes completely and making them unstable. Notice this bridge here, underneath this bridge, a very severe water problem, totally eating the front slope away from that. Maintenance now has got to come in and regrade that slope and backfill probably with granular material and try to stop that erosion. But in the process of repairing that slope, we must provide some way for that water that's continuing to come down to get away. One of the design problems, I think, and I've commented to bridge designers before about this, notice the stains on the front of that bridge seat there. Notice there's water coming from the top, down through the expansion dam and down over that seat, staining that bridge. There needs to be some way for that water to be carried off and not brought down over the seat. That's what's the major cause of erosion here, I believe, at this site. And notice again, another situation just like that. Stained, notice the seat there and the bridge, or pile cap, are stained with water, probably coming through the expansion dam and down over the slope. This slope, someone has tried to stabilize it. It looks like with bituminous material, possibly. They've tried to stabilize that to keep that from eroding any further. And that's a continuing maintenance problem that we ought to be aware of. Every drop of water that gets into the front of this slope and causes either erosion or saturation is going to destabilize or add its part to destabilizing the slope. Here's another example of water stains on the front of a bridge abutment. Notice that lots of water has come down over that bridge in the past, and it's got to go somewhere. In this case, it's been going down over the front of the slope. Notice here is a good example of what to do to carry some of that water away. In this particular site here, they're actually carrying that pipe a long way, several hundred feet away from the toe of that embankment to keep that from saturating the field and the toe of the field. Paved slopes. Now we have paved slopes many times in front of bridges. If there's a paved slope, it needs to have weep holes in it. There needs to be a way for the water to build up, that builds up behind that, and I guarantee you water is going to build up behind that slope at some time during the life of that structure. There needs to be some way to get out from behind that slab. Notice there are no weep holes that I can discover at this site, but it is weeping. And there is water behind that slab, and you can see that in the cracks. Notice the stains on the front of that. Now that water backed in behind that slab, it's trying to get out, is obviously destabilizing that bridge approach. And it's softening the soil there and keeping that slope, the shear strength of that soil below what it could be if it were draining properly. So providing weep holes somewhere along that paved slope, as this sketch shows here, either at the bottom or maybe part of the way up, will go a long way in helping to stabilize the bridge approach and keeping that moisture content down. Here's one that has a weep hole in it. Notice it's not doing very well. Down at the bottom in the lower right part of the picture, there's a weep hole in the middle of that big stain area. It's not performing all of its job because also the water you can see is coming out above it. Stains on up above that weep hole. If there are weep holes, they ought to be cleaned out as much as possible. Either go in and clean them with a drill or with a bit or core into them and insert a perforated pipe inside that weep hole and try to help drain and relieve the water pressure a little bit. If you've got retaining walls or something of that nature, of course, you need to come back in also. If they do not have weep holes in them, maintenance should provide some. Again, by drilling in through that wall and trying to put a pipe in there, a perforated pipe of some kind with an end closed, hopefully to relieve some of the pour pressure or the water pressure behind it. On a new construction, if you're constructing a new wall, maintenance is doing something like this, to put a granular material behind it with a geotextile fabric to keep the fines out of it, or nowadays even you can go with prefabricated drainage panels. Various companies make these things. I've got a picture here, I believe, of one. Yes, this is a prefabricated drainage panel behind a retaining wall. This is a timber retaining wall with soldier piles, but that black wavy thing in this picture there is a prefabricated panel that has not been completely compacted yet. So these things help to reduce the water pressures behind walls. Maintenance can do this in their activity if they're building a small wall or trying to maintain one. One other thing here very quickly before lunch, and we'll finish up on this, is road surface maintenance. Now, some people would ask the question again, what does maintaining the surface of the pavement have to do with stability of a slope? And but again, we are talking about today here, every source of water that you can think of is going to add to a slope instability. So we're going to try to avoid getting any surface water off of that pavement down into the slope, either into the foundation or into the side slope or whatever. So road surface maintenance is important. Again, I want to emphasize, if there are joints in the pavement, if it's an old concrete pavement, those joints should be sealed. If there are cracks in an asphalt pavement or fissures or anything like that, it's good to seal them. Some people have questioned over the years whether that sealing does a lot of good or not, and whether it extends the life of the pavement. Well, in this particular case, we're not speaking from the point of the pavement, but from the point of the slope, point of the embankment. And in that particular case, sealing is good to prevent surface water from getting down further into your slope or into your embankment. So yes, I agree. I think sealing the surface of a roadway is very, very beneficial. This little sketch here just repeats the same thing. Any tension crack you may have, not just pavement cracks, but any tension cracks, and I mentioned earlier already, should be sealed in the pavement as well.
Would you discuss what to fill those cracks with?
All right. Again, if it's in the pavement, and I'm talking about a paved surface, there are all kinds of materials that can be used. Most of the time they are an asphalt emulsion. Sometimes if it's a wide crack, you can actually put a fine asphalt concrete mix in it, but most of the time it's just an asphalt emulsion. Harrison, I think you and Harrison Reed here, I think both of you all are seal cracks a lot. What do you all use for yours?
It's normally an emulsion or maybe a little heavier grade material than that, larger cracks.
Okay. Harrison, I know the city of Lexington pours a lot of them too. So usually it is an emulsion of some type. They're all different kinds and grades, but that works usually the best. If it's a large tension crack in the soil, then I would backfill it probably with a granular material and then seal it again with an asphalt material of some kind. Here's an example of a pavement edge joint. This is a primary source of water, a very big source of water in asphalt pavements or concrete pavements. In this slide here, it's a concrete pavement. But here you see the joint here is actually falling in. That needs to be sealed by maintenance. Again, we're thinking now from the term standpoint of protecting your slopes and your embankments from saturation. All of this water, if we can keep it out, is just going to have us that much ahead. Just a pothole even a pothole can present problems for us. If we were and these are particularly true on thin county roads and where you have thinner surfaces, maybe just 1 or 2 inches of asphalt on top of maybe of a granular base, a gravel base or whatever. It doesn't take very long for the water that's in this pothole to get on down into the subgrade soil, particularly on a thin pavement. Maybe on some of our higher class highways that may not be such a problem, but I'd say on a county road it's more of a problem. Just to show you that yes, a lot of water does make difference. I must give credit to the Asphalt Institute for this slide. Just simply shows you a tire at the joint of a concrete pavement, and they caught it at just the right moment. There's a lot of water under that pavement and possibly in that embankment as you see it squirting out there. And one other point here before we finish for lunch. Utilities, and I'm often irritated at utilities as I drive around town because it seems like as you pave a street or a highway, they've got to come and cut it up immediately, and that often irritates me. But utilities do add sometimes to our problems, and just briefly we'll mention the fact that there's some things that really should be done here. That if utilities are actually on our highways and they're cutting into the roadway, they shouldn't be permitted to interfere with the subsurface drainage. If there's a water table there or whatever it may be. Notice in this sketch here we've got a trench at the toe of this cut slope. Notice how it intercepts the water table. If that water table is disturbed, and if it was a stable situation before, it could destabilize it now. We don't know. But they should be carefully monitored as much as possible, as much as personnel are available to make sure. If they open up a trench and keep a trench open for a very long period of time, that trench should be drained. There should be some method of drainage. If, as I've shown here in the sketch, if you can't run a pipe out to the edge of the slope and beyond the slope, possibly pumping it, keeping it pumped dry, whatever it may be. Something needs to be done. And really the real killer in most installations of utility construction are patches. After they've been patched, they come back and they settle many times. This allows water to stand in them and causes problems. Notice in this slide here, this is what should not be done. This is utility construction. Off to the left, lower right, or excuse me, off to the lower right of the picture, there is a slope. This was at the top of the slope, as a matter of fact. And water was standing in this trench. I personally remember it stood here for over a week. Water in this particular location. That should not be permitted to do, and the slope, I'm sure, received lots of good saturation from that point. And just to show you a sunken patch, you can't see the edges of the patch too well in this slide, but it does show that water can stand in your pavement. Again, it's going to saturate your subgrade for sure, but chances are it could even get down into your slope and damage your slope as well. So that pretty well finishes our maintenance practices and the things that we would invite you to look at, maintenance people to consider. And so it's about 11:45, and that's about the time we should have finished for lunch. So let's go to lunch. Calvin, you want to give us any instructions?